Hello everyone! In this video content I will introduce you with Raspberry Pi Pico and Micropython. So first we will compile the Micropython binary for the Raspberry Pi Pico on the Raspberry Pi 4. Then we will start to coding and testing some Hello World applications. Micropython is the implementation of the Python for embedded devices. Okay, you will understand better after this content, after this video. So first, go to the repository of the Micropython. We need to clone it. To clone, you should copy this link from here and open the terminal, create some directory. I just gained in Pico. Then clone it here. Just paste the link, just you copy it. Enter this directory. Then init the submodules. Actually update the submodules for the specific Pico SDK. This should be line, not an equals sign. Okay. So go to this Pico SDK directory, then update the submodules here. It will install the necessary directories to compile. Also, before compilation, we need to install a few packages to check actually they exist. CMake, GCC, the compiler, the toolchain, and build essential also it's necessary. Let's install these. Then go to the directory to before and call make mpy cross -c also. This creates the make file actually to call the make. Then after this we call the make to compile to get the Micropython binary for the Raspberry Pi Pico actually. Okay, I'm not sure that you can run these things on another on the Linux machine, I don't know, but these are working in the Raspberry Pi, Raspbian. Maybe some other steps should be taken. Okay. Probably these things can take some more time for you, but I'll just cut the video to not to bother you. Now go to the directory of the Pico SDK, cd ports RPI, not a Pico SDK. Then make here. After this, it will create the related binary for the Micropython. Then in the next section we will copy this file to the Micropython. Okay, but first we have to make the Raspberry Pi Pico ready for this operation. So now we will copy UF2 file to the Raspberry Pi Pico. It is simple. We will just drag and drop. That is all. Go to the build directory and find the firmware UF2 file. This one. This is the necessary file. So let's take the Raspberry Pi Pico. There is a button, the white button on the board. Boot cell button. Before plug the USB part, you should push this button. Okay. Push this button. Then plug the USB to the Raspberry Pi. After a few seconds, or immediately, I don't know, the directory will be pop up as a USB stick. Let's wait a little bit. Like this. So open in File Manager. So this is the Raspberry Pi Pico right now. What we will do, we will copy this firmware UF2 file to this directory. So here, open a window, find the firmware UF2 file. Where is it? This one. So copy or drag, whatever you want. However you want, you can do it. I will simply drag and drop like this, drag and drop here. Then this window will be gone. So right now we are ready to use the Micropython on the Raspberry Pi Pico over, of course, serial connection, USB connection. So let's test the Micropython. Let's write simple Hello World application. There are a lot of ways, of course. We will install the Minicom for the USB part, right? So I already installed before, but if you don't have, you can install like this, sudo apt install Minicom. This will do serial terminal emulator simply. You can open Minicom -o-d dev tty acm0. This is the Raspberry Pi right now. So the terminal here right now. So you can type the Python commands like this, for example, print hello world, something like that. So we are in the Raspberry Pi Pico and it is working right now. So we can run the Python commands, right? But that doesn't mean we will use like this, right? So let's first try to access the hardware also. Let's turn some LED on, the onboard LED on actually. So import the libraries from machine import pin. This is for the GPIOs on the board. So just create a LED variable. Pin 25 is the onboard LED. And we will make pin out, which means, digital output. So when we write the LED, LED dot value 1 means LED will be on, like this, easy. So when we write LED value 0, then LED will be gone, turn off. So this is not a good usage, right? So let's install the Thonny interactive development environment for the development, for coding easily. So sudo apt install Thonny. Then I will also show you how you configure your interactive development environment for Raspberry Pi Pico. Okay, I already installed this one also. So let's run, like just typing the Thonny. But before, also we should install the wheel file, which is necessary to configure the Thonny for the Raspberry Pi Pico. Okay, this is simple. Just go here and in the releases, you can find the wheel file, wheel package actually. Then here in assets, this one here, see. Just install like that, then go to the directory. Okay, So just it is in this directory, don't forget. Run the Thonny. This screen is a little bit not bigger for me here, sorry about it. Then from tools and manage plugins, we should install as a locally here. Okay, we don't have the Raspberry Pi Pico right now, as you understand, right? So go to end of this window. There is an install from the local file. Click here. Then choose the wheel file. It will install for this Thonny interactive development environment. Then close it. Sometimes if this is not work, if this will not work, then you can restart the Thonny. Sometimes this can be happen. Okay, don't forget. Of course, this is not enough to run the Python commands over a Thonny. So you see that this is still in the shell. There is a normal the local Python is exist, but we want to run the Micropython. So go to tool, and from the options, go to interpreter. Here choose the Raspberry Pi Pico Micropython here, and choose here as we did before from the Minicom, choose to TTY part and click OK. If I can find the OK here, let me put uppers, yeah. Then let's check it is working. I think it is not working. Yes. Why it is not working? Probably we chose the wrong TTY. Yeah, this is correct. We have to choose the correct one. Let's go to again to the options. Yeah, I know, don't worry. Yes, just close this. Go to options again. Raspberry Pi Pico, this one is correct. Let me check again. And this one, yeah, the board in FS mode. Yeah, this one should be. Now, yeah, we are in the Micropython, as you see. Just close this. So we can simply print a hello world. So it's simply like before we did with the Minicom, right? Just print hello world. Yeah, it's working. It's good. So let's create some timer and to blink the LID on the board. I will follow the documents, the official document in the Raspberry Pi website generally for this tutorial. Also, you can find these examples there, and not maybe same, but closest there. Okay. So import the pin again from machine, import pin. This will give us related functions to access the hardware, and the timer to create a timer to periodic events. Create the LED variable, the pin 25, and the onboard LED LID. We will use another GPIO in the next as an out, as we did before. Let's create a timer and define the callback function, which is name a tick. Timer here, and the global LID, and let toggle. This will toggle the LID, right, on and off, true and false, true, false, true, false, like this. So call the function, team init function actually, timer, time init. The first argument is the frequency of the toggling. Right, let's try 3 or something like that just now. This one is mode, this periodic it should be. And the third one is the callback function, which is the tick, as you see right now. So Control S, save, and to the Raspberry Pi Pico, not to this computer. Then it will send the code, the Python code, to the Raspberry Pi Pico, like we did before. Okay, click the Raspberry Pi Pico here. Choose the Pico one. And it's asked for the name, just give it a main Python, main py, main py. This will be the beginning the function, right? This will call at the startup, main py. Okay. So push the green one, the run button. Let's check. So it's working. It is blinking. It is toggling actually, right? So if you want, you can play with the frequency. Like for example, let's change to 1, something like. Let's click the green button again, maybe 6. After each saving, you have to run the code, right? But there is no big difference for my eyes here, if I didn't make any mistake. So let's change this number to around 7. No, not much big difference still. Okay, let's 10. Yeah, it's a little bit faster right now. So I think we can increase more. 30, for example. Yeah, it is much more faster. So we increase the frequency simply. So 40. I'm not sure to increase. I'm not sure it's a good idea to increase more, but let's try. 50. And probably you cannot see after 60 or something like that because of the video, I think, the camera. Maybe I can see with my eyes. Yeah, I can see with my eyes here. Also from the video, I cannot. Yeah, you cannot see, right? It is toggling actually right now a little bit. So 70, 90. That's working. Okay, there is a problem. So don't play much with the frequency. Okay, it is stuck. So you can, in this case, you can just power off and on the Pico. Okay, so, or you can just send the UF2 file again. It doesn't matter, but stuck here. So it wasn't a good idea to increase more the frequency. Whatever. And let's type some another example. As you know, in the Pico there is a temperature sensor, right? So let's use this temperature sensor to read the temperature. This built-in temperature sensor we can use. So ADC we use here, this is the 4, which is in the built-in, connected to the built-in temperature sensor. There should be a conversion factor that I just found on the internet. I didn't prove it, it's correct or not, I don't know. Just typed. Six five five 3 5, yes, correct. Then in the while loop, to print the temperature, reading sensor read SU16, right, times the conversion factor, temperature 27 minus reading 0.7606. Yeah, this one I found 0017 from the internet actually. I just try with you right now. Print the temperature, time, sleep, and let's put sleep here, 3 or 2, it doesn't matter, just run. And 16 degree, 19 degree, no, there is, I'm sure there is not 19 degree here. This is wrong. Let me check. Yeah, I checked with the another sensor which shows me around 25. This is wrong. So I think that you can change the conversion factor, or there is something, I don't know. I don't wanna check right now. If I typed everything correct, I don't know. Conversion factor reads U16, I think. Well, it doesn't matter, it is working, right? So we can read the analog value like this. Okay. So as you know, as we know actually, on the Raspberry Pi Pico, some pins can behave like a GPIO, analog digital converter, and SPI, I2C, whatever. So let's try one of the GPIO right now, one of the pin, which can behave as a GPIO, digital output, also analog input. Okay, I will simply connect one LED and one potentiometer. I will use the 31, the pin number here. First, I will try to simply blink the LED there to connect, or let's connect first the potentiometer to see the analog value here. Just we change this, the last example a little bit, that will be all. So let's read first then the analog value, I think, right? So remove each these factors we don't need. So I connect the potentiometer, as you see it is working. We can see the change here. Okay, good. So let's add the related code for the GPIO, for the LED. Import pin timer like before we did, but we will not use right now the built-in LED, right? This is the 26 that you can see on the image, right, on the picture. So this will pin out and remove these. This also can be removed. Create a timer here, create a callback function, and global LED ID, LED toggle. And init timer with the frequency, not much. We tried before, it's not a good idea. And as a periodic mode, and just give the callback function as a third argument. Okay. Device is it says, and let's send the code. Yeah. Let's turn off the light. Yeah, it's working right now. I just put one LED and one resistor here. So don't do this like that, okay? Please solder these things. So we can change. It's working. So in the bonus side, as a bonus, so you can remove this Raspberry Pico actually from the Raspberry Pi right now. So because you have to file it is inside, then you can plug in your computer, for example. You can find directly the port and the COM, COM number, the port number here, the 5, and using, for example, another terminal emulator like here, PuTTY, it's a PuTTY, whatever it's called, and type the baud rate. You will access the same shell here. You can type here any Python command, right? You can type whatever you want. You can do whatever you want right now from any computer, anywhere. At least if you have an USB connection, you have USB access, then you can type, you can code the Raspberry Pi Pico anymore. So that is all for me here, guys. Thank you for watching. Don't forget to subscribe and see you again.